Let's go ahead and talk about limits. When you have a limit of x squared minus 1 over x minus 1 as x approaches 1, when you plug 1 right away, you get 0 over 0, which is indeterminate. So if you recall, when we did this kind of problem, what we had to do was we first had to simplify. So when you factor x squared minus 1, you get x minus 1 times x plus 1 all over x minus 1. Then you're able to cancel out x minus 1. And then you plug in 1, you get 2. But there are cases when you can't really factor. And this is what I mean. So now we have limit of natural log of x over x minus 1 as x approaches 1. So when you plug in 1, you get 0 over 0 again, which is indeterminate. Unlike the last example, you really cannot simplify this. So what are we supposed to do in this case? Well, that's why we have a L'Hopital's rule. When you have limit and you plug in a value and you go 0 over 0 or infinity over infinity, it doesn't matter what kind of sign this is. It could be negative infinity over positive infinity or positive over positive infinity. Whenever you have that case, we have to apply L'Hopital's rule. And what is L'Hopital's rule? Well, this is what you got to do. Limit as x approaches 1. You take the derivative of the numerator and derivative of the denominator separately. So what is the derivative of natural log of x? It's 1 over x. And what is the derivative of x minus 1? It's 1. And you plug in 1 and see what you get. Well, you get 1 over 1, which is 1. And that will be the limit. And this is a good time for you to graph this on your graphing calculator and see what happens as you approach 1. You'll notice that the y value that it approaches is 1. Now, let's take a look at limit as x approaches infinity of e to the x over x squared. What happens as x approaches infinity? Well, if you look at the graph of e to the x looks like this. So as you can see, as x approaches infinity, the y value goes to infinity. So it will be infinity on top. And what about x squared? Well, x squared is a parabola. So as x approaches infinity, y value also approaches infinity. So this is a case where you have infinity over infinity. So what do? You apply L'Hopital's rule. So what happens? What's the derivative of e to the x? Is e to the x over derivative of x squared, which is 2x. What happens when you put infinity? Again, is infinity over infinity. So what do? Well, you apply the L'Hopital's rule again. Yes, you may apply L'Hopital's rule more than once. So derivative of e to the x is e to the x. Derivative of 2x is 2. What happens when you put infinity? It's going to be infinity over 2. Well, what is infinity over 2? It's a big number over 2, which is going to be what? It's going to be infinity. So the answer will be infinity. Now let's do something more challenging. When you look at this example, when you plug in 0, what is tangent of 0? It's going to be 0 minus 0 over 0. So you have 0 over 0, which is indeterminate. So what do we apply? That's right, L'Hopital's rule. So when you apply L'Hopital's rule, you're going to get derivative of tangent x, which is secant square x. I'm going to rewrite it like this. so that it's easier for us to take the derivative. Minus x, so that's -1, over derivative of 3 x squared, x cubed is 3x squared. So what happens when you plug in 0? What is secant of 0? That's 1 over cosine x. Cosine of 0 is 0, 1 over 1. So secant of 0 is 1, 1 minus 1 over 0 is again 0 over 0. So we have to do it again. So apply L'Hopital's rule. You get limit as x approaches 0. What is the derivative of that? 2. You have to apply chain rule. Times the derivative inside, which is secant x. Derivative of -1 is 0, all over 6x. Now when you simplify that, you are going to get 2 secant x, quantity square tangent x, over 6x. Now, what happened when you plug in 0? Unfortunately, you get 0 over 0. So when we simplify, we could get rid of 2 and 6, and we get this right here. Unfortunately, when you plug in 0, you get 0 over 0 again. So we have to apply L'Hopital's rule. And we're going to get secant x, quantity secant x squared times derivative of tangent x, which is secant square x, plus tangent x times the derivative of secant square x, which is going to be 2 secant x times secant x tangent x, all over 3. The derivative of 3x is 3. Now, when you plug in 0, you're going to get 1 times 1 plus 0 all over 3, which is going to be 1/3. And that is going to be your final answer.